Okay, problem 1. Limit px is 4, limit qx is pi, limit rx is 3. So first part, what is the limit? Right, pi px plus qx minus here's qrx. Okay, first part, it's the sum of these three, right? And all these three limits, they should exist. Then the limit of the sum is the sum of the limit. Okay, so okay, then this part, the limit of a constant times function is a constant times the limit. Okay, and this part, the limit of the product, so you can see both functions limit exists at this point, right? So the limit of a product is the product of the limit. It's the product of the limit. Okay, so now you can sub in, right? So it is 4 pi, right, plus pi minus 3 pi. Okay, so the answer is 2 pi. Okay, part B, the limit px plus qx over rx. So now for the quotient, because now the denominator, the limit is not 0, so it is the limit of the numerator. And for the limit of numerator, you can further split it because both limit exists. So it's sum of the limit over the limit of rx. Right. So one thing is that if you use this, all these limits must be, all these individual limits, they must be defined, so you can split it, right? If any of this is not defined, you can't use this method. So it is 4 plus pi over 3. Okay. Problem 2. Limit. For example, find the limit x is approaching half pi cosine x. So now cosine x is a continuous function. So at any point, the limit at that point is cosine that point, right? Because cosine is continuous, so you can just sub in. Right, again, 179, this is a continuous function, right? When x is approaching infinity, right? Because the value, the limit equals the function's value, right? But the function's value is always 179. So the limit is 179. Limit x is approaching 3 from the left side, right? And here is a polynomial. The polynomial is continuous. So when you get the limit, you can just sub in. Okay, then the last part, limit y is approaching 3. So 4 to the power of y. Right, so the exponential function is continuous, so the limit at point 3 is the function's value at point 3. Okay, so here you can sub in if the function is continuous at the point. Okay. Problem 3. The limit x is approaching 1 So this is a complicated function, but you can see as long as this function is defined, it is continuous because it is a combination of basic functions like x over a power 1 polynomial over another power 1 polynomial square root, right? So as long as this function is defined, it is continuous. So at point 1, this function is defined, so the limit when x is approaching point 1 is equal to f1. Okay. So all the problems in part 3, they follow the same logic. It looks like a complicated function, but it's a combination of basic functions. So it's continuous as long as the function is defined at that point. Then the limit is the function's value, right? So here, again, you just have to sub in 1 minus 1 square. Okay, so it is sine 0. It is 0. Okay. So tangent 2 minus x squared pi over 3. All right. So for tangent, for example, as long as x is not half pi, right? X is not negative half pi, it is continuous. So now x is, when you sub in x, it is pi over 3, right? So tangent pi over 3, it should be square root of 3. Okay, lowering absolute value of x minus 2. So again, it's continuous as long as it's defined. So you can just sub in lowering 3 minus 2 is lowering 1. Lowering 1, it's 0. Right. Last part, limit tangent inverse. Right. X is approaching square root of 2. So it's x squared over 2. Right. Again, you can just sub in its tangent inverse 1, right? So it's pi over 4. Okay.